Hi, I'm Ed Ackerman from Photonic Systems Incorporated. We call ourselves PSI. I'm going to demonstrate for you the operation of one of PSI's new products, the Interference Eliminator, which is in this box here. I'm going to step through a demo of this twice. First in a sort of executive summary fashion, and second in a more detailed fashion showing what piece of equipment, each piece of equipment in the test setup is doing. Now the purpose of the interference eliminator is to address a very difficult situation where you have a signal of interest but that you're trying to receive from some distance away, while there's some other closer antenna transmitting a much stronger signal, which we call the interferer. So it's difficult, and it might be right in our band of our signal of interest, so it's going to block our ability to receive the signal of interest with good signal to noise ratio. How that's usually addressed, if possible, is this way that I show in the diagram, not with an eliminator of the interference, but what's called can be accurately called an analog interference subtractor, where you have two inputs and one output. One of your inputs is your antenna that is sensing your signal of interest and your interferer, and a second input where you take a copy of the interfering source and signal source and feed that in, so that you do a subtraction, so that the output is just leftover of what's not in common on these two inputs, which is your distant signal of interest. Now, and as I mentioned, what's nice about that is even if they overlap in bandwidth, you will subtract just this from this and get that. But that's the case where the transmitting source is accessible. You have a way of pulling off what we call a reference copy so that you can do the subtraction. The eliminator, not shown here, but rather in this diagram that I'm going to put on our high-tech overhead projector here, it does not need that reference copy that we saw in the last diagram. Instead, it is smart enough to figure out what's the interferer, what's the signal of interest, and eliminate the interferer, even though it's stronger and even though it's right in the same band as our signal of interest. So let's get started now on our demo. What I'm going to do first is turn on the signal of interest alone and modulate it with an AM signal, an audio signal. And you'll hear the audio signal on this radio at the output of our test setup. Then before engaging the interference eliminator, I'll add an interfering signal that's stronger than the signal of interest. It's going to be plus 5 dBm, about 20 dB stronger than our signal of interest. And first I'll place it outside the channel to which we've tuned the radio. And when you do that, the radio has a nice bandpass filter in it, so it's good at getting rid of the interferer and letting us hear the signal of interest. But then I'll tune the interfering frequency so that it's right in the middle of our signal of interest bandwidth, and then you won't be able to hear the signal of interest, the audio signal. Then I'll turn on the interference eliminator, and you will be able to hear the audio signal because it's eliminating that in-band interferer. Okay, so let's begin. First, as I said, I'm going to generate the signal of interest. For the purposes of this demo, I'm going to use a CW tone at 3.7 gigahertz, 3700 megahertz as this displays. And we'll see that on our spectrum analyzer here. There it is. Now I'm going to amplitude modulate that with an audio signal, which is going into our AM port here, and it's just the Beatles' Hard Day's Night. And you'll see, there's our audio signal. It's got about 20 kilohertz of bandwidth. And let's listen to it on our radio. There we go. All right, now the next thing I'm going to do is add an interferer. And let's see, when I add that, first I'm going to start with an out of band. There we go. It's at plus 5 dBm. It's stronger than our signal of interest tone, and it's on AM modulation, but it's outside the band, the channel of the radio right now. But now I'm going to move it around. See it moving around and leaving the signal of interest frequency alone, moving around the interfering frequency. And when I get too close, there, it prevents us from hearing the signal of interest. Instead, we hear this audio tone that's at the difference frequency. See, it goes down as I get closer and up as I don't know if you can hear that on the film. So that's problematic, like I said. And without a reference copy to subtract it, how am I going to eliminate it? Well, the eliminator does. And going to switch it, engage it in now. And there it is. It's been suppressed a lot. It's still there a little bit. You can still hear a little bit of that difference frequency, but mostly you just hear Hard Day's Night. And let me show you again where our interferer is. It's way down there, so that I can dial it right into the bandwidth of our signal of interest. And even when it's right on top of it, I can still hear Hard Day's Night. Not as well when it's right on top, but I'm getting rid of it. I'm getting rid of the interferer quite effectively. And just to show you, I didn't do something else while I was moving things around. There's when I turn the interferer off, and then here's when I disengage the interference eliminator. There's my interferer again, preventing us from hearing the signal of interest. So now, if that's all you want to listen to and don't want to hear a detailed description of our test setup, I'll end there just mentioning before you leave how to get a hold of me. Again, my name is Ed Ackerman, and here's my phone number and my email address, and thank you for listening. So now, let's step through our test setup. We don't need to hear that anymore, and I'm just going to put on a more detailed description again with our high-tech. Let's put it a little higher. There we go. So again, the interference eliminator here. What was I doing when I was engaging and disengaging? Well, I've got two 1x2 switches in this arrangement here, so that when the switches were off, I was bypassing the interference eliminator with, as shown by this arrow. When the switches were on, I'm going into it and then coming back out before going out to my receiving setup. And there's no antenna, but there's a signal combiner here, a 3 dB combiner, in which I'm combining the output of my interferer signal generator here, putting out plus 5 dBm, and my signal of interest 3.7 gigahertz, also at that same frequency, and with my AM port here with the modulation from the iPod. And then at the output of the interference eliminator, I've got this coupler here that let us both display what was going on and from a spectrum analyzer, and hear it on the radio. And obviously, the radio doesn't work up at 3.7 gigahertz. I had it tuned to about a kilohertz, so we were using an LO to beat against the input frequency to mix it down to a kilohertz to be heard on the AM radio. So that's our test setup that you just saw me demonstrate the interference eliminator inside of. And if we'd love to field any questions you have. We can customize this for many different signal situations and different bandwidths and all sorts of things like that. Please get a hold of us. Thank you for listening.